variables from coefficients are a little bit different. Remember that a coefficient is a number that multiplies or divides a variable. In the examples below, circle the variable term in each of the equations. So in example 1, you see the variable of x, but a variable term has a coefficient with it. What's the coefficient of that x? Well, I see a negative sign, but negative what? Negative 1. There's that invisible 1. If you don't see a coefficient in front of a variable, remember that it is 1. But coefficients always have signs to them. In this case, that negative went with that 1. So let's circle that variable term. In example 2, we have x over 4 is equal to 3. Our x is being divided by 4, therefore 4 is a coefficient. So the variable term is x divided by 4. We circle the whole thing. In the third example, 6 is equal to 2x over 3. So we have a 2 beside our x, which means multiply, and a 3 that's under, which means divide. So therefore, the whole thing is your variable term. So the key with isolating variables from its coefficient is you have to use the inverse of multiplication or division to isolate the variable from its coefficient. So in our first example, what is the operation of the coefficient? There you see a negative 1 that's beside our x. A coefficient beside a variable means multiplication. That's like saying negative 1 times x. The inverse is just the opposite. So what's the inverse operation of multiplication? Division. So in order to isolate this variable of x from its coefficient of negative 1, I would have to divide it by negative 1. Notice though that the sign of the coefficient does not change. The constants, when we were combining like terms, yes, those change when you cross the line, you change the sign, but not with coefficients. Regardless if you're multiplying or dividing, whatever the sign of the coefficient, you will multiply or divide that number with its sign. The whole point of that is whenever you have the same number with the same sign on the top and the bottom of a fraction, it will always cancel out. After it's canceled, then our variable is all by itself. But we do have to apply the golden rule. Whatever we do to one side, because we divided by 1 on one side, we must also do to the other side of the equation. So we divide by 1 on the other side as well. After that, you have to use your rules of multiplying or dividing integers. Remember, this is not SOB. We gave you many different techniques to remember multiplying and dividing integers. Here I gave you the sine triangle again. Let me just remind you how that works. You have a positive 4, so you cover up a positive sign. Over a negative 1, so we cover up a negative. Therefore, our final answer has to be negative. So you have x is equal to negative 4, because 4 divided by 1 is 4. Be careful with that. I can't tell you how many people put 1 for that. So again, I have another memorization technique. Everybody seems to love this one. If it's beside it, you divide it. So if you see a coefficient or any number that's directly beside a variable, you will always divide it. Beside it, divide it. It rhymes. So look at example 2. What is the operation of this coefficient? Well, the coefficient is 4 and it's under our variable. So the operation is division, because whenever you have a fraction bar, the number underneath is just saying it's being divided by x divided by 4. The inverse of division then is multiplication. So what you will do is multiply that x over 4 by 4. This will cancel out because you'll have one number, you'll have the same number, one that's up high and one that's down low of the fraction. that will cancel out. But we have to apply the golden rule. Whatever we do to one side of the equation, in this case we multiply by 4, we have to do to the other side. Then you use the rules of multiplying and dividing integers. So our x is all by itself, and 3 times 4 is equal to 12. So of course, I've given you a rule or a memorization technique. If it's under, you move it up and multiply. You can just say under, up, and multiply. Because what we did there is we had that 4, and we moved it up and multiplied. And then we move that up and multiply to both sides of the equation. So in example 3, 6 is equal to 2x over 3. What are the operations of the coefficient? Well, we have an x with a 2 beside it and a 3 under it, so we have both operations being applied here. The 2 is being multiplied to x, and the 3 is dividing the 2 and the x. To always perform inverse multiplication before you apply inverse of division to isolate a variable. So what we mean by that is the first thing you have to do is under, up, and multiply. So we're going to multiply both sides by 3 because our denominator, or the number that was underneath our x, was 3, so we multiply both sides of the equation by 3. That cancels out the 3's. And then we use the rules of integers. 3 times 6 is 18 is equal to 2x. The 2x still remains. Then you beside it divide it. So under, up, and multiply, then beside it divide it. So we're going to divide both sides by 2 because that's the number that's beside our variable. The 2's then cancel out because we have one that's above a fraction bar and one that's below. 18 divided by 2 is 9, is on the left, and then our x just comes down on the right. So we have 9 is equal to x. Or you can rewrite it in standard form of x is equal to 9. Sorry, get a question here. To check an answer, you can do so by evaluating the number. So here I have a problem. Is 6 a solution to the following equation? Let's say you did all your work, decided to divide it, under, up, multiply, or cross the lines and change the signs, whichever rules you applied, and you get a value for your x. Okay, in this case 6. We want to know, is 6 the correct answer to the equation? What you will do is evaluate the expressions on both sides, or just rewrite the entire equation, but wherever you see a variable, notice I put a set of parentheses. That's sort of like a little hole or a placeholder. So I rewrite it with our hole. Whatever answer that you get when you solve the problem, you plug it into that hole. Whoops, sorry, my thing's in the wrong order here. Okay, let me try that again. So you had 7x equals 42. You recopy the equation, but you leave that hole. The value that you solved for, you plug into that hole. And then you evaluate each side of the equation separately. So just looking at the left-hand side of the equation, we have 7 times 6. Because there's no variable, now we can use our order of operations here. And there's nothing inside our parentheses. The 7 next to the 6 in parentheses actually means multiplication. 7 times 6 is 42. So does that equal 42? Yes, it does. So the solution checks. Well, what if you got 8 as the solution to the same equation? Let's try that. Again, I will copy down the problem, or the equation, the original equation, but wherever I see a variable, I'm going to put a set of parentheses to be a hole or a placeholder for my value. I want to know if 8 is a solution, so I'm going to plug in that 8 inside the hole there. Well, what's 7 times 8? It's 56. Does 56 equal 42? No, it does not. So the answer of 8 is not a solution. The few minutes extra that it would take for you to plug in your answers into the equation to check your answer is worth your time. Few minutes of checking to make sure that each one of your answers are correct will guarantee that you pass the class versus retaking a full 8 weeks because you just simply wanted to take the extra few minutes to check your answers. On the ECA exam, with any extra time that you have, please, please, please go back and check all of your answers by plugging them back into the original equation. Alright, let's practice a few of these before you do your guided practice. These types of equations that we are solving are called one-step equations. One step because you are either going to combine like terms or you're going to isolate a variable from its coefficient. When I say combine like terms, we're combining our constants. So to solve each one of these problems, I would advise you to do these in about 4 steps. Now, one of these steps you're going to combine, or you're going to skip. You're either going to get to skip step 2 of combining like terms because there aren't like terms to combine, or you're going to skip step 3 because there aren't any variables to isolate. So, our first step, identify the types of terms. This will help you to determine what you're going to do next. So let's identify our terms. We have a variable term, a constant, and a constant. Now you're going to ask yourself, well, which of these 2 steps do I have to do next? Well, look, what do you have? Do you have any coefficients that you need to isolate? No. Do we have any constants that we need to combine? Yes. We have a constant of positive 3 and a constant of 11 that we need to combine together. But before we combine them, we need to get our variable, the x, all by itself. So what are you going to get rid of? The 3 or the 11? Did you say 3? And what would you have to do to get rid of the 3? Create a 0 pair. So we're going to subtract 3 from both sides of the equation so that we have that 0 pair, and we follow the golden rule of whatever we do to one side, we have to do to the other. Then you combine, or draw your big fat line and combine your like terms. So x is equal to, and when you combine, you have to remember to use SOB. 11 and a negative 3 are opposite signs, so we have to subtract. 11 minus 3 is 8, and our bigger sign wins. So it stays a positive 8. We do not have any variables in front of our, or we don't have any coefficients in front of our variable except for 1. So we're done. Okay, there's only a coefficient of 1, then you're done. X is equal to 8, but let's check our answer. To check, remember, we write down the original equation, but wherever we see a variable, we put a set of parentheses to be a placeholder. Then you're going to plug in your answer of 8 into that spot. Evaluate just the one side of the equation and then the other. 8 plus 3 is equal to 11. On the right hand side, the only thing we have is 11, so we just copy it down, 11. Does 11 equal 11? Of course, so our answer checks. The answer to the equation is x is equal to 8, and we proved that the answer is definitely 8. Looking at the next problem. First thing, identify your terms. So let's circle our variable terms. We only have one, and put a square around any constant terms. In 81, we only have 1. So we finished step 1. Step 2, we need to combine any like terms. Do we have any like terms to combine? No, so we get to skip that step. Step 3, isolate the variable from its coefficient. Yeah, we have a variable here and it's not by itself. We have a 9 that's beside it. So what do? If it's beside it, you divide it. Yay. So we divide both sides by 9. Beside it, divide it. The whole point of dividing by the 9 is that it cancels out the 9s, 9 over 9. So k is equal to, and 81 divided by 9 is 9. We have a positive divided by a positive, which equals still a positive. Yeah, they're both the same sign, so it stays positive. 9. All right, let's check. Make sure we did get the right solution. So I'm going to copy down the original equation, 9 times k, but I don't write down k, I just put a set of parentheses to leave a hole, equals 81. I almost wrote 18. 81. Then I replace or plug in the 9 that I got from my solution, and multiply 9 times 9 equals 81. Does 81 equal to 81? Oops, I wrote 18 again there. 81. Yes, so the answer checks. Alright, you tried this one on your own. Push pause and see how far you can get, and then push play when you're ready to go. Alright, we're ready? By the way, as I'm showing you the answer, if you make a mistake anywhere, then please pause the video again, finish and correct your mistake, and try to rework the problem, then push play to keep on checking. Alright, so my first step is identifying my terms. I've got a variable term, a constant, and a constant. Did you remember to put the negative in with the 9 inside that constant? Alright, so I finished step 1. Now I need to combine any like terms. Do I have any like terms to combine? Yep, I have a negative 9 and a 4. See how those squares are kind of like our training wheels? They're training our eyes. Hey, we've got 2 squares we need to combine together. But right now they're not on the same side of the equation as one another. So we have to move the 9, the negative 9. And when we move it to their side, you need to make that 0 pair to move it. So we need to add 9. Follow the golden rule, add 9 to both sides. So we draw our big fat line and we're ready to combine. The 0 pair cancels out, and we have y is equal to 9 plus 4 is 13. The bigger sign wins, so it stays positive 13. Then, did you check your work? Y, but instead of y I made a parentheses, minus 9 is equal to 4. It's the original equation, but instead of writing y, I made a set of parentheses. Then I'm going to plug in the 13 that I got for my solution and simplify the expression. 9 minus 13, or I'm sorry, 13 minus 9 is 4. And because 4 is equal to 4, check, I did it right. Alright, try example 4. Push pause and then push play when you're ready to check. Hopefully even in the last one when you plugged your answer in and checked it, if you made a mistake you were able to catch it before you even watched the video. Alright, are you ready to go? First things first, let's identify our terms. We have an x over 4. So that is a variable term. You circle the whole thing together. Is equal to 11. 11 is a constant because there's no variables with it at all. Do we have any like terms to combine? Nope, we got a variable term on one side and a constant on the other. Those aren't like terms, so we get to skip the step. Then we need to isolate our variable from its coefficient. Here we have a 4 that's under. What's the rhyme? Under, up, and multiply. So you multiply both sides of the equation by 4. The whole up thing is going to help you out, especially if that 11 was not just a whole number, if it was a fraction later. So do say that whole rhyme, under, up, and multiply. It'll make more sense later why I emphasize the up. The 4's cancel out, so x is equal to 11 times 4 is 44. And then you can check your work. Here I have that hole or that placeholder where the x is over 4 is equal to 11. Now you're probably thinking, why does she keep on making a set of parentheses? Trust me, later on when we get some more complex equations, the parentheses are really going to make a difference. So we're going to replace inside the parentheses the 44, our solution that we had before. So we have the number 44 divided by 4. which does reduce to 11. So does 11 equal 11? Of course it does. So you check. Alright, you're ready to begin your guided practices. Now remember that when you do these equations, you're going to have a mixture. Some of the one-step equations are going to be ones where you have to combine your constants together. So you have to combine like terms. In other equations, you're just going to be isolating your variable from its coefficient. Doing that first step of identifying your terms, like using the circles and squares, are really going to help you understand or know which step to apply. Good luck on those.